Awesome. Thank you, Michelle. Mahalo, everyone, for joining us today for our 2022 Lā Honua Malama Honua Earth Day, Earth Month, especially to our HCC Kauhale that includes our community of students, staff, and faculty. These events have been made possible by the Lā Honua Earth Day Committee, the Office of the Chancellor at Hawaiʻi CC and Hilo, the Office of Sustainability and Vista Sustainability Initiatives Program at Hawaiʻi CC and Hilo, the Tropical Conservation Biology and Environmental Science Graduate Program at Hilo, I'ola Haloa Hawaii Lifestyles Program at Hawaiʻi CC, Kipuka Native Hawaiian Student Center at Hilo, Pacific Internships for Exploring Science Pipes at Hilo, Keaholoa STEM at Hilo, and the Sustainability Committees of Hilo and Hawaiʻi CC. For this year, our theme for Lā Honua is Wanana Ika Mauʻoliola, Projecting and Manifesting a Thriving Earth. The session that you're in right now is titled A Threat Close to Home, Occurrence of Microplastic Ingestion by Zooplankton in Hilo Bay, and it'll be presented by Emma Gordon. My name is Anya Benavides, and I'll be serving as the moderator for this session. The session is scheduled to run until 4:00 p.m. We ask that you try to do your best to remain in the session until it ends. If you must leave early, you may do so, but please do it as discreetly as possible. If you have any questions or feedback during the session, feel free to use the chat and I'll pose them to the presenters at the end of the session. The presenters may also invite verbal questions or feedback at the end of the session or even verbal interaction throughout the session. Please be considerate of any requests made by our presenters. We are privileged and honored to have them share with us and ask our audience to be attentive and respectful. You will eventually be emailed a survey, which will also be accessible on our Lā Honua website. We would love to receive your feedback about your Lā Honua experience. With that, I'm going to turn it over to Carla McDermott. She's going to introduce Emily briefly. Emma.
Okay, yes, Emma. I'm very proud to introduce Emma. She's one of my senior thesis students in Marine Science 471 this semester. And all the students have a requirement to give a public presentation of their work over and beyond their normal marine science symposium at the end of the semester. So Emma took the plunge, and I'm excited that she chose to speak at this venue. I think her work grew out of a class that she took from me and Steve Colbert called Marine Debris in the Pacific. And she knows an awful lot from the types of plastic to the fates of plastic to the effects of plastics. And she designed this senior thesis project based on that knowledge and the knowledge gaps. She brought the issue here to home to Hilo Bay, and I think you will, I don't know if the word is enjoy, but I think you will learn a lot from Emma today. Emma?
Thank you so much. I'm just gonna make sure the screen sharing is working. Does everyone see that? Great. So like Carla said, my name is Emma Gordon and I am a senior thesis student here. And I will be talking to you all today about the occurrence of microplastic ingestion here in Hilo Bay, Hawaii. So the planktonic community is highly important to the marine environment and the ocean ecosystem as a whole. There are two portions. There is the phytoplankton, which is the photosynthetic portion of the planktonic community, and zooplankton, which is the animal portion of the planktonic community. There are organisms that spend their whole lives as plankton, such as krill and copepods, and there are some that only spend a portion of their lives as plankton, such as larval crabs, sea urchins. They play highly important ecological roles. They can be prey for economically valued species such as shrimp, sardines, and herring. And they are also primary consumers that prey on phytoplankton and contribute to nutrient cycles. They are also important contributors of the carbon cycle through grazing of phytoplankton. Of the zooplankton that you can find in Hawaii seawater, copepods were the most abundant that I found. There are two major orders, calanoid on the far left, which has 46 families across marine and freshwater, with 5 commonly found in Hawaii, and cyclopoid with 30 families, 2 of which are commonly found in Hawaii, and the middle and the far right images. There were also lots of decapods in the samples that I was sorting. From left to right, there are zoea and megalops, which are both different stages of decapod larvae. Zoea is the first stage after nauplius and is characterized by long rostral and dorsal spines, and megalops is the stage after zoea, where the legs and abdominal appendages have formed and the eyes have become much larger. On the far right are lucifer shrimps, which are a genus of prawn that are sometimes bioluminescent. Others that are common are lots and lots and lots of teeny tiny mollusk shells, as well as larval fish and chaetonaths or arrowworms, which are predatory marine worms that can be found around the world, including in polar regions. Plastic production began in the 1950s and has increased 205 times as of 2016, and this value is expected to triple by 2060. Plastic waste and litter are a huge hazard for marine organisms. They can cause entanglement or gastrointestinal blockages, both of which can turn out to be fatal. It's currently estimated that 14 million tons of plastic waste enter the oceans annually. This can come from human activity on beaches, sewage, and river transport, just to name a few. And of that 14 million tons, it is estimated that 90% of that is microplastics. Microplastics are plastics that are less than 5 millimeters in length. There are primary microplastics, which are manufactured at that size, such as beads in beauty products or scrubs, or synthetic fibers in clothing. And there are secondary microplastics, which are fragments of larger plastic pieces. This could be from wear and tear on car tires, paint on roads and signs, and even damage to shoes can produce microplastics. We have known about microplastics polluting the oceans since the early 1990s, and they now pollute every single marine environment. Microplastics have been found in nearshore and offshore waters, sediments in the water column, and across a gradient of human interaction. Microplastics have also been found in all manner of marine organisms, from megafauna such as whales to seabirds, fish across a range of trophic levels, and recently zooplankton. Due to the nature of plastics, they are extremely slow to degrade, and plastics can remain in ocean ecosystems for long periods of time and continue to be available to marine organisms, which may consume the plastics incidentally. As I said before, plastics are extremely dangerous to consume. They can cause gastrointestinal blockages or damage. Some are made with harmful chemicals, and others have the potential to sorb, transport, and release harmful pollutants and toxins. The concern regarding microplastics in the marine environment has been growing, especially plastic consumption by marine organisms. As zooplankton are prey for many species that are economically and ecologically important, zooplankton consumption of microplastics is an area of growing concern. It is possible that microplastics consumed by zooplankton can transfer across trophic levels and accumulate in larger organisms. There have been studies conducted worldwide in China, South America, and the East Coast of the United States. And recently there was a study conducted on the western portion of the island of Hawaii regarding larval fish and their interactions with microplastics. Of the studies that I've been reading, most have found approximately 2 to 4 microplastics per cubic meter of water and approximately 1 piece consumed per 100 zooplankton. My objectives with this study were to determine the presence, amount, and types of microplastics found in Hilo Bay, both inside and outside of the breakwater, and whether or not zooplankton in Hilo Bay are consuming microplastics, and if they are, how many they are. So over 4 months, I performed 10 plankton tows and collected a total of 5 liters of seawater. My sampling locations were based on inside the breakwater. I really wanted to get as close to the mouths of the Wailuku and Wailoa rivers to see if the rivers possibly affect the amount of microplastics present. I also wanted to sample near Reed's Bay, which has a much higher human interaction with fishing, boats, and recreation. And then outside the breakwater, wanted to make sure I got a few locations there, because outside the breakwater could mean less human interaction and possibly a chance for microplastics to disperse more. To collect samples, I did 10-minute long horizontal surface tows with a 150 micrometer net with a 20 centimeter mouth diameter. And attached to the net was a general oceanics ink flow meter so that I would be able to calculate the zooplankton and microplastic density. And once the tows were completed, zooplankton were stored on ice on the boat. And then at the lab, I transferred them to a 5% formaldehyde seawater solution. Zooplankton I collected were stored in 500 milliliter jars. And in order to count zooplankton and potential microplastics, I did 10 20 milliliter subsamples per jar. In each 20 milliliter subsample, I counted every single organism that was present and classified them down to the lowest taxonomic group possible. I used the Zooplankton Taxonomic Guide published by the University of Tasmania in Australia to assist with zooplankton identification. As I was counting zooplankton, I was also counting, categorizing, and storing microplastics. I classified the microplastics by the 3 types most often seen in other studies, which are fragments, fibers, and beads. And while counting and sorting zooplankton and microplastics, I was also selecting 50 individuals from select taxonomic groups to digest in acid at a later time to determine if they had consumed microplastics. In chemistry, digestion is the process of decomposing organic matter by bacteria, chemical action, or heat, so that way there's only inorganics left behind. The taxonomic groups that I used were calanoid copepod, cyclopod copepod, Decapod, Myceta, polychaete, and Chaetonaths, and these were taxonomic groups most often seen in literature for this kind of study. The 50 individuals from each group were transferred to 20 milliliter scintillation vials. I then rinsed them 3 times with deionized water and added 100% strength nitric acid and digested the zooplankton for 3 hours in a hot water bath of 80 degrees Celsius. At the same time, to account for possible contamination, I ran blanks of the tests, which were vials with nitric acid, but no zooplankton, to see if any microplastics were being added to the vials. And I found no contamination throughout my digestions. 100% nitric acid is also an extremely strong acid and has the possibility to affect certain plastics like nylon, polyethylene terephthalate, and biopolymers, but it has frequently been used in previous studies of this manner. To account for the possible loss, I performed a separate test where I selected different plastics that I was seeing in my seawater samples and put them through the digestion process. At the end of the 3 hours, none of the plastics I had selected had been digested. And in order to analyze what was left over, I neutralized the acid with baking soda and then re-examined what was left over after digestion to see if any microplastics remained. So during my time in the lab, I counted a lot of zooplankton, 18,420 to be exact. Of those, the calanoid copepods were the most common because there are 5 calanoid families of copepods commonly found in Hawaii versus only 2 families of cyclopod copepods. Not on this graph, I also found 4 megalops larvae and 10 larval fish. In my samples, I found 985 microplastics in 2 liters of seawater. For every 1 plankton that I found, there were approximately 0.32 microplastics in the water as well. 46% were fibers, 45% were fragments, and only 9% were beads. The majority fibers holds true with previous literature, as fibers have the largest input to seawater from sewage and laundry wastewater. For example, 1 wash of laundry can produce thousands of microplastic fibers. As for my digestions, I digested a total of 3,000 plankton, and I found 35 microplastics that had been ingested. This is about 1.16 microplastics per 100 zooplankton, which lines up with literature and studies from other locations. Of the plastics that I found, there were 25 fibers, putting them at 71.4% of the microplastics consumed. And of the zooplankton digested, calanoid copepods had consumed the most plastics, 8 in total. So the reason that I decided to do this study in particular is because I think it is very important, as plastic pollution poses one of the largest threats to marine ecosystems. The high production rate and slow degradation of plastics means that they accumulate quickly and can remain in the marine environment for many years to come. Microplastics also have the potential to enter the marine food web with zooplankton and remain in the food web for a very long time. as zooplankton are key prey items for and an invaluable food source for many commercial species, such as small fish like herrings and sardines, crustaceans like shrimps, and even some benthic organisms such as bivalves like clams all feed on zooplankton. Not only can they enter the food web, but microplastics pose a possible toxic risk to organisms that accidentally consume them. Additives such as plasticizers, flame retardants, and antimicrobials are added during manufacturing to plastics, and some man-made chemicals such as PCBs and DDT can adhere to the surface of plastics. And this is very dangerous because it is possible that microplastics and those additives they contain can be transferred through trophic levels in the same way that phytotoxins from harmful algae can travel through trophic levels. Microplastic ingestion by low trophic keystone organisms like zooplankton may result in trophic transfer of these dangerous chemicals that can then accumulate in higher trophic organisms that may then be captured and sold for consumption. And as a community, it is our job to educate not only ourselves, but others of the possible threats that microplastics pose. We can work together to avoid single-use plastics that can break down, as well as cosmetics that contain microbeads, and choose cosmetics that have organic scrubbing agents instead. The image on this slide shows a study from the University of Plymouth that had found how many microbeads were in each of these bottles of a sort of facial scrubber or cleanser. And proper disposal of plastics can help as well. Even flushing items that are not meant to be flushed, such as wipes, can create huge amounts of microplastic fibers. Along with this, it is our responsibility to research legislation regarding plastics and the environment, and to support community outreach events like this one and cleanups when you see them. I would like to thank everyone who helped me get to this point. Thank you very much for your time. And are there any questions?
I'm sorry, you may have commented on this earlier, but how long did this entire process take?
So I've been planning out this thesis for over a year, and then it was 4 months to collect all of the plankton toes. I started in October and finished in January or February. And then as for the sorting and the counting, I was spending approximately 16 to 20 hours in the MSB lab a week to finish all of them.
Did you do it all by yourself?
I sure did.
All the counting? Wow. Amazing. So this is a big issue, as you've just stated. I'm curious as to if you know of any specific legislation that may be pending, or like specific ways we could, I guess, get involved with policy change, because it's
excuse me, sorry, go ahead.
No, it's okay. Well, I was just gonna say, it's like, it's hard when we feel like we can do all that we can, but it doesn't really, like, these big companies are what are the main issue. So if there's any like advice or anything that.
Well, the most recent one that I've encountered is a ban that's attempting to go through right now on styrofoam, because styrofoam is made out of lots of little teeny tiny plastics that break down into those pieces. So like styrofoam food containers are going, styrofoam coffee cups, that kind of thing. There's also, yeah, she's got one right there. It's all styrofoam. But it's definitely a lot of things like that. I'm personally not as aware of the policies that are going through right now, and I'm more aware of kind of a product side of things, I guess. Like there's traps that you can buy for both your dishwasher and washing machines to try and catch microplastics. It's kind of like a little net that you can then dispose of those properly, or at least make sure they don't end up in the ocean. And like beauty products, especially, that study in Plymouth had been done where it was comparing products from 2015 to 2018, and the microplastic content had decreased, but they're definitely still in a lot of beauty products that people are not aware of. And they're called micro beads, and some of them try and sell it off as like being an organic scrub of kinds, but they're still plastics.
Emma, I'm wondering how you feel like we always talk about how in Hawaii, we're in the middle of the Pacific, we're far from all these things, right? But what you found is that the microplastics were similar to other places, right?
Right.
How do you interpret that, or what does that make you feel? Did you expect something different?
I don't know that I was expecting anything different, because I think that wherever there is a large enough human population, we are going to be finding these kinds of results. And there's also, my results are not as expansive as the other studies that were being done, and they were sorting so many more plankton, and they were doing seasonal. There was one in the Yellow Sea in China that was looking at rainy season versus dry season. There is another one in China that was looking at directly, I kind of copied some of their things where they were looking at river outlets and then further away from human impact. So they actually had a map where it showed more microplastics the closer to humans, versus as they got further away from human impact, there were less that were being consumed. And it's kind of just an incidental thing where it's not like the zooplankton, they're probably not out there choosing to eat microplastics. It's just that especially like beads and fibers are just very easily consumed. A lot of the ones that I was finding that had been consumed were less than 2 millimeters. So these were really, really tiny plastics that were being consumed. Lacey,
Emma?
I saw you.
Oh,
I was just gonna ask, so I may have missed something, but you said like the overall concern is because it's accumulating in larger animals, but at like a basic level, when is that kind of detrimental to zooplankton if you know that information?
It's less about it being detrimental to zooplankton and more about if we can show that it's entering at zooplankton. And then you think of creatures that eat zooplankton in mass. It's not like one zooplankton and done. It's lots and lots and lots and lots and lots of them. And if it continues through the trophic levels, there are some studies that have found microplastics in women's breast milk. There's studies that have found microplastics in human blood. I was hearing from Michelle, there's one that's finding them in lungs even. And it's definitely more of the zooplankton. Most of them are able to pass the microplastics pretty easily. I found a study that was about whether or not the microplastics caused any kind of detrimental effect to the zooplankton, and they themselves weren't actually being hurt in most cases by consuming microplastics. It's more of a threat of it building up over time and possibly releasing those toxins.
Awesome, thank you.
Hey, Emma, we have a question from Carla. Did you see any differences between inside and outside of the breakwater?
I didn't see any differences as far as which toes had more or less microplastics consumed, because most of them were pretty much the same across the board. It would only be like 1 or 2 here or there. But what I did see a difference was in that inside the break wall, there was a huge amount of microplastics. One of my toes inside the break wall, I think had something like 205 fibers versus ones outside the break wall would maybe have like 5 or 10.
so just floating in the water, you saw
Right.
differences. Okay.
I guess that's kind of interesting because you would think if there's more plastics in the water there, you'd see more of a difference, but maybe with longer term studies, it might show a difference. I don't know.
Could be, because I only had a few months to work on this versus the ones that I'm looking at. These are all relatively recent studies too. Like I think the oldest one I found was maybe 2014 or 2015, and there's more coming out like in 2022 and 2021. All these studies are continuing to come out about zooplankton eating microplastic.
Did the study in Kona, that was on fish though, fish larvae?
Yes.
Or did they digest, or did they did they acidify the fish, or did they dissect them and they found microplastics?
I'm actually not positive on whether they digested or did acid. But I know that they were looking at all sorts of larval fish, and they were
But
finding
not-
at least
not
some
copepoda.
interactions. No, they were looking specifically at larval fish,
Okay, so
of
yours
which I
is
only
the-
found 10.
All right, but yours is the first study on this island
As far as I'm aware.
on invertebrate, on zooplankton. I mean, not fish, but copepods and lucifers and all that kind of, yeah.
As far as I'm aware. Do I think the number would change during a high tourist season versus a lower tourist season? I don't know that tourist season would have too much of an impact on it. I didn't find any studies that were looking at that, but definitely looking at like rainy season versus dry season. And the reason I don't think tourist season would have much of an impact is because a lot of the microplastics that we're looking at are mostly fibers, and those are coming from people who live in those areas and are doing their laundry and are maybe flushing things they should not be flushing down the toilet and producing those microplastics.
I think this is like the question of the hour for everything, but how do you think we can continue to, because you kind of touched on this, but what are some other ways you think we can continue to raise awareness in our communities, like maybe within the university, but also outside in the wider community?
I mean, it's definitely doing things like this are really, really cool. Like I don't know if this is the first time this has happened, but this is the first time I've heard of this. Things like this, even though there's not, as many people that signed up that showed up, there's still enough people here that could say, even like over dinner, hey, I heard a talk today about like microplastics and how they could end up in zooplankton or in fish and then eventually make it to the dinner table. And that's not really a good thing. Or like, hey, did you know actually that cosmetic product is not very good for the environment? Maybe you should pick this one with apricot seeds instead. It's definitely, I think word of mouth and more studies like this are our best way to go, because that's how I never thought about zooplankton eating microplastics until I found an article about it. And I was like, look into that.
Well, we're going to encourage, one scientific way, Emma, we're going to encourage you to publish this. I don't know if that reaches the broadest public, so maybe you're going to have to give this talk many times.
I have also a recording too, so there's that. People can watch it later. Sorry.
Oh, sorry, it's not really directly related to Emma's presentation, but just made me think about maybe more collaboration between campuses. I work at the community college. If we could have students like Emma come into our classes and give a presentation. I teach English, so I'm thinking, man, if I have a student who wants to write something about this, but they don't have a lot of information, having another student come in and share these ideas would be a really nice way to approach it, students learning more about this topic and then maybe even choosing to explore or write about topics like this.
I'm definitely all for that. What is the name of the filters for our washing machines? Let me look that up.
Later. That now I want one. I want one for my washing machine. But you can tell me later. You can tell everybody later.
It looks like they're actually just called microfiber filters.
Okay.
It's pretty straightforward.
Anyone with any further questions for Emma?
Thank you.
I would like to very much thank Emma from the Lā Honua committee for giving this talk. This was incredible. And as a UH faculty member, we are so proud of you for doing this research. And if you get this published, you're the first one for the Big Island, right? Everyone has to build off of yours. So I just want to thank all of you for being here. We're going to go ahead and stop the recording right now. If you need to hang out afterwards and ask more questions, please feel free to do so, but it is 4 o'clock. So we're going to go ahead and end our recording. Thank you all for showing up.